Today we are going to see problem on design of knuckle joint. Okay. So in previous lecture we have seen there are three parts of knuckle joint: single eye, double eye, and pin. And also we have seen this 2D diagram in detail. So today we are going to design a knuckle joint for the given problem. That is, a knuckle joint is to withstand a load of 150 kilonewton. Design the knuckle joint if permissible stresses are 75 MPa, 60 MPa, 150 MPa in tension, in shearing and compression. Okay, so first we will write what are the data given to us. That is, data given to us. Here you have to mark this permissible stress. Okay, it mentioned that we are given permissible stress, so we need not bother about factor of safety. Okay, we have to directly take this data, that is sigma t is given as 75 MPa and tau is given as 60 MPa. Then sigma c is given as 150 MPa, and you all know that sigma c is nothing but it is a parameter to check sigma ck. Okay, 150 MPa. This data is given, and also we have been given P or W is equal to 150 kilonewton. So 150 kilonewton is equal to 150 into 10 raised to 3 Newton. Okay. So this data is given to us, and they are asking us to design for the knuckle joint. Now, first step in designing of knuckle joint is failure of rod in tension. So failure of rod in tension. So sigma t is given as W upon pi by 4 into d square. Okay. So sigma t value, we know sigma t is 75. And W also we know that is 150 into 10 raised to 3 divided by pi by 4 into d square. So from here we will get the value of d, and the value of d is, okay, now I'm giving you time to calculate. Yes, the correct answer is 50 point. The correct answer is 50.46 mm. So we are rounding it off by saying 52 mm. So we have taken D as 52 mm. Okay. Now first step is completed. So we have find out the diameter of rod which is connecting. Now step number two is to design a single eye. Okay, or 2 to 5. Then we are having this. We have to fix all the dimensions. All the dimensions. You can see in first step we have calculated D. So we got the value of D. So from here we can easily write down by looking at this table. This table you have to memorize, okay, later on. So D is equal to D1 is equal to how much? 52. Then next is what? D2. D2 is equal to twice of D. So it is equal to
104.
104. 104. Then D3 is equal to 1.5 times of D. So it is equal to
78.
78 mm. All are in mm. Okay. Then T is equal to T is equal to 1.25 into D is
65.
equal to 65 mm. Kindly turn off your mic. Kindly turn off your mic. All of you. These are very simple calculation. Okay, 1.25 times of D. So this is what I'm asking you. Then T1 is equal to T1 is equal to 0.75 times of D. So it comes to be 39 mm. It comes to be 39 mm. Then we are having T2. T2 is equal to 0.5 times of D. So it comes to be 26 mm. So in step number two, we have to calculate D, D2, D3, T, T1, T2. Now these are the values. These are the values. Okay. So we have calculated D2, we have calculated D3, we have calculated D1, D1, and we have calculated D. Then in second step number two, we got all the values. Now we are going to check these values whether these values are safe or not. Okay. For that, now we will start designing. That is step number three is checking single eye in tension. So this is a single eye in tension. So here we are having a formula, that is step number three. Now we are solving. We are having formula sigma t is equal to W upon d2 minus d1 into t. Okay. So here value of W is 150 into 10 raised to 3, and value of D2 is 104, and value of D1 is 52. Value of D1 is 52 multiplied by thickness is 65. Okay, this is the expression. Now from this expression we will calculate the value of sigma t. Now tell me the value of sigma t. Please calculate on CNC.
44.37.
44.37.
44.37.
Okay, we got value is 44.38
37.
MPa. Okay, now we will compare this value. We will compare this value with the value which is given in the question. Okay, the value which is given in question are the safe values or permissible values for the design. So after comparing, you can see the sigma t is given in question is, or to design is 75 MPa. So after putting this dimension, it comes to the 44.38 MPa. Means our design is safe. Means our design is safe since it is less than sigma t permissible. Okay, sigma t permissible, less than sigma t permissible. Design is design for design for single eye design for single eye intention intention is safe. So understood all of you? the value which are we have taken in previous step, like d2 d1. So after putting this value, we are getting sigma t is equal to 44.38, okay, which is less than sigma t permissible. And sigma t permissible is how much? Sigma t is permissible is 75 MPa. So I'm writing here for you, sigma t permissible is 75 MPa. So you can compare value. This 44.38 is less than 75. So this design is safe for D2 and D1. Okay. Now we will move to the next step, that is checking the failure of single eye in crushing. Checking the failure of single eye in crushing. So now again I will apply a formula, sigma ck. Sigma ck is equal to W upon D1 into T. Okay, D1 into T. Now here again the W is 150, 150 into 10 raised to 3, and D1, the value of D1 is 65, and the value of T is 52. So this now you calculate the answer and tell me the answer.
Sir, same 44.38.
44.38.
The answer is same, 44.38 MPa. The answer is the answer is 44.38 MPa. Again, see, the value of sigma c is given to us, so it is also less than sigma ck. Okay, and this sigma ck is how much? This sigma ck is given in example, that is sigma ck permissible is how much? That is 150 MPa. 150 MPa. Okay, so means design is safe for design is safe for again here you will write one statement, design is safe for design is safe for design is safe for failure of single eye failure of single eye in crushing in crushing in crushing. Okay, now we will move to the next step, that is checking the failure of single eye in double shear. Checking of failure of single eye in double shear. So we are having again formula, that is sigma t is equal sorry tau is equal to shear stress, we are representing the tau is equal to W upon d2 minus d1 into T. Now value of W we know, that is 150 raised to 3. Value of d2 is 104 minus, this is 52 into 65. Okay, so from here we will get the value. Tell me the value again for the tau.
Sir,
Sir,
same answer.
Same as same.
same.
Yeah.
Same as same.
44.38.
Same answer.
Sir, same.
44. Okay, the answer of tau is 44.35 MPa. Okay, so again you will compare this tau with the tau permissible. Tau permissible is given, so it is less than tau permissible. The value of tau permissible is how much? 60 MPa. So this is also safe. So you will write design. One statement you have to remember: design for failure of design for the failure of single eye in double shear in double share is safe. Okay. Now we will move to the next step, and the next step is now start for the fork end, that is checking the failure of fork end in tension across the slot. So checking the failure of fork end in the tension across the slot. So formula for this, that is sigma T, is given as W upon 2 into bracket D2 minus D1 into T1. Correct? So this is our formula. Now again we know all the values. We will substitute 150 into 10 raised to 3 again divided by 2 multiplied by D2 is how much? D2 is a 104 and D1 is 52 multiplied by T1 is 39. So from here we will get the value of sigma T. Now calculate and tell me the value of sigma T.
36.9.
36.98. Okay, 36.98 MPa. Now again we will compare this value with the permissible value of sigma T. So again we will find out this is less than the permissible value. Permissible value is how much? Permissible value of sigma T permissible, is nothing but sigma is nothing but a 75 MPa. So again you can see here this 36.98 is less than. So again design is safe. Design is safe. Design is safe. Okay, you can also write this small statement, but you have to show this this less than sigma T TP permissible. That is then again now next we will move to the next step, that is checking the failure of fork end in crushing. Okay, fork end in crushing. So we are having formula sigma ck is equal to W upon 2 multiplied by D1 into T1. D1 into T1. So value of W is 150 into 10 raised to 3. Again, the value of D1 is 39 and T1 is 52. So sigma ck is equal to, now tell me the value of sigma ck.
Sir, same
Sir, same hai.
36.98.
36.98.
Okay, 36.98 MPa. 36.98 MPa. Again, this 36.98 is less than sigma ck permissible. Sigma ck permissible is how much? Sigma ck permissible is nothing but 150. Okay, so it is less than sigma ck permissible, and this is 150 MPa, which is given in question. So again, design is safe. Again, design is safe. Design is safe. You can also write this small statement, design is safe. Now we will move to the next step, that is design of fork in for the double end. Now here we are checking the failure of fork end in sharing. Okay, checking. So again we will apply a formula, that is tau is equal to W upon 2 multiplied by D2 minus D1 multiplied by T1. Okay, so value of W is 150 into 10 raised to 3 divided by 2 multiplied by T2 is 104. T2 is 104 minus 52 into 39. Okay, now tell me the value of tau.
Sir, same answer.
Same है sir.
36.98.
Okay,
Thirty five point three one.
36.98 MPa.
It's not nine.
36.98 MPa. Okay, which is again less than tau given. Tau permissible is how much? Tau permissible we have given 60. Tau permissible is 60. So again it is less than 60. So design is safe. Design is safe. Design is safe. Okay. Now we'll move to the last step, that is design of pin, checking failure of knuckle pin in shear. You all know in knuckle pin there is a double shear. Okay. So tau is equal to W upon 2 multiplied by pi by 4 into d1 square. Since this is in double share, so we're indicating 2. Okay. So from here again you substitute value 150 into 10 raised to 3 divided by 2 multiplied by pi by 4 into d1 square. The value of d1 is 52 mm. 52 square. So tau. Now tell me the value of tau.
35.31.
35.31.
35.31, sir.
Tell me the yes, correct answer. Yes, correct answer. So tau comes to be 35.31 MPa. Again, this 35.31 is less than the value tau permissible given. The tau permissible is how much? Tau permissible is 60 MPa. So it is less than 60 MPa, means design is safe. Design safe. So whatever, we have fixed the all dimension in step number 2. So different dimensions like d, d1, t, the all dimensions which we have fixed in step number 2, that all are the safe dimensions. So after this you will draw the diagram of knuckle joint and you will list down the all the values which we have given in step number 2. Okay, this value.